We are live.
Awesome.
Okay, I'll start. Question 3. The true linear regression equation y is equal to beta 0 plus beta 1 multiplied by x, where beta 0 and beta 1 are known. What are the null and alternative hypotheses for beta 1? I chose the third one down. Equal to 0 and not equal to 0.
Yeah, equal 0, not equal. Yep.
Okay, question 4. A residual is
Is that the difference?
The observed value y and the value predicted by the regression line.
Yeah.
Mm-hmm.
So the third one down.
Yep.
Oh, we've got 18 questions today.
Oh, geez. All right. But they're going pretty quick so far, so this is good.
Okay. Plot of residual supports using linear regression when
look normally distributed.
Yep.
yeah. You're not supposed to see a pattern. I was about to pick that one, and I remembered.
Mm-hmm. Okay, for the next 8 problems, use the data found in math self-efficiency. Use the confidence variable as the explanatory variable and the score variable as the response variable. Compute the residuals for the data using software. What statement best describes the residuals? Okay, I gotta plug that in.
So which one is it again that was supposed to be the the response?
It says they use the confidence variable as the explanatory variable.
Okay. 6-4. So glad when they tell us which one to use instead of guessing and getting it wrong the first time.
Yeah, that's nice. Yeah, because that last quiz, they didn't tell us, did they?
No, they didn't.
Oh, wow. So on question 6 is compute the residuals for the data using software. What statement best describes the data? The residuals form a linear pattern. And that's just with, I just plotted a QQ plot.
Wait, is that residual pattern the QQ plot that they have going there, or is that something else?
No, it's in quantitative descriptive statistics. So one of one of the requirements is that the residuals perform or need to be normal. So that's how you check normality of the residual data, is that you create a QQ plot.
And you're using both the explanatory variable and the residuals to make the QQ plot, right?
No, so
just use the residuals, right?
Just the residuals on the QQ plot, but
because mine came up wrong. So
yeah, you do use the explanatory and residuals when you're checking, and those should show no correlation.
And then the QQ plot, you said you make that on the other spreadsheet?
Yeah.
And I'm trying to find where I put that spreadsheet. Which one is that one called? That's the descriptive one? Right?
It is, let's see, quantitative descriptive statistics, and it's got histogram and descriptive stats and QQ plots.
Hmm.
Yeah,
that's right. Yeah, it's been a while since we used that.
Yeah, it's been quite a while.
Mine's taking forever to load the data into the QQ plot.
No, I was just using the QQ plots for the data that I was running this morning, and I was having trouble finding the file again.
Is it in your recent files? Would it be there?
For some reason, it wasn't. Oh, I know what happened. For some reason, my system has 2 different versions of Excel.
Hmm.
And it pulled the data. It opened it up in the other version now than I did earlier.
That'll do it.
Now, on that QQ plot, you have to sort it, correct?
You do. Yep.
You have to sort it?
Yeah, if you don't sort it, it'll look random.
Okay.
Okay, that is definitely normally distributed.
Mm-hmm.
For some reason on mine, maybe you guys have seen this, but so I do that. So I put in the data. It comes up with how it should be distributed, and then it changes them all to reference.
Yeah, if you just
paste
paste those values.
Paste values, right? Okay.
Yes.
Sweet. Thanks.
So that should give you your linear pattern, correct?
Yeah,
That'll do it,
yeah. It's almost a straight line, so yeah, they're normal.
So 6 is obviously a linear pattern. 7 would be their fairly normal. Ooh, now we get a scatter plot. Don't they already do that one?
No, this is the scatter plot using both the residuals and the explanatory variable.
But don't they do that in the, I thought they already did that in the quantitative inference with the linear regression model. They have a scatter plot there at the bottom.
No, that's explanatory and response. So there's 3 different plots. There's explanatory and response, explanatory and residuals, and then a QQ plot of the residuals. Those are the 3 different checks.
Okay. So we did QQ. So you'd use the residual and the explanatory variable to make your new scatter plot, correct?
Mm-hmm.
Okay.
Dang it.
I'm getting them all kind of distributed toward the right side.
But there's no real pattern though, right?
Right.
No, there's no pattern. You insert a trend line. It shows that it's pretty flat.
Mm-hmm. Yeah, it's not really decreasing or increasing there. So what would we put there for number 7? That it's, are they right skewed?
Well, there's definitely, for 7, the residuals, that's the other line, right?
So for line 7, it was the residuals are fairly normal.
Yeah, because they were pretty linear.
Oh, because they were straight. Oh yeah, I missed that one.
Yeah. So question
8.
It's a good question. I don't know.
Okay, so there's definitely a linear relationship between X and Y.
Mm-hmm.
And we know that the residuals are normally distributed from the last question.
Correct.
Mm-hmm.
Observations are independent.
Okay. And we don't really know if there was any error in the data. measuring
how would we
the
know
X
that?
values. So I think those are the only ones we can really
it's the-
specify.
The first, the third,
And the fifth.
and the fifth.
So, well, but the second one is the normal error term. The variance of the error term is constant for all values of x, and the way that we check that is the QQ plot. And the way to make sure is that the points on the QQ plot are close to the line, which they are. So I would
Okay.
say first, second, third, and fifth. Because we
Say
don't
that
know.
last thing. Then with the second point, the variance of the error term is
Wait,
constant.
wait. There's the 5 different requirements for simple linear regression. So it's got to have all 5 of them to be a true linear regression.
So, and it's the 4 that we can check. You can't check the x values.
Well, they say when it's saying the requirements, they say x are fixed and measured without error. In other words, the x's can be considered as known constants.
Right. But there's not a way to check that.
Okay.
So given the scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data?
Gotcha. Okay. So everything but 4, right?
Yeah.
Okay.
Okay.
What is B1? The estimate for the slope.
Well, hold on. Sorry, go back to question 8. The observations are independent. We can't really check that either.
Okay.
But
So when it says the observations are independent, would we have to do a whole separate test to test for the independence?
Oh, we have to do the chi-squared test.
Yeah. That's what I was wondering, because
yeah, so it wouldn't be part of the, I guess, that the data that they're asking about.
Okay.
all right. So the next one for the answer, I got 12.695.
Wait, so on the last, but before that, do we do that the observations are independent?
No.
No.
No, right? Okay. And you got 12.695, Skylar said?
Yep. That's what I got. What did you guys get?
Same.
Yeah.
Okay, cool. And so for the confidence interval of that, are we doing the confidence interval of the slope, or are we doing it of the y-intercept?
What did we list last time? I
For
forgot.
B1 would be the slope, right?
I think he said we're always doing the slope in this class,
Okay.
but let me double check. In this class, we will always be looking at the slope, which is the bottom of the predictors.
Okay.
Perfect.
So
10.674.
For down is 14.715.
Cool.
I didn't accidentally click into my formula itself, and yes. 12, which is based on the evidence and using the level of significance of 0.05. What decision would you make regarding the hypothesis test for B1? Well, our p-value is obviously less than that.
Mhm.
So we would reject the whole null hypothesis because the p-value is less than the level of significance.
Right. So that'd be B, our second one down.
C in mine.
Oh, yeah, because, p-value is less than alpha. Yeah. That's what I meant. Okay, cool. For hypothesis tests for beta slope, if you reject the null hypothesis, what does it mean?
So wouldn't that be there's sufficient evidence to conclude that the slope of the regression line is not 0?
Right, because then you would go to the alternative, which is that it's not 0, right? Not equal to 0.
There's sufficient evidence. So the
There's
last one,
sufficient
right?
evidence. Is not 0. Yep, that'd be the last one.
They almost always get me with the wording on that one.
Someone told me that it was like, so if you reject the null, then you go to your conclusion is that you have sufficient evidence for the alternative hypothesis. Or
That's kind of the way I've always worded it too.
Okay.
right.
Head length was, okay, sorry. For the next one, we're supposed to use that data that's modified. Head length was used to predict body length. So explanatory variable would be head length and body length would be the response variable, correct?
Right. So the dependent is the body length.
So the dependent variable,
The dependent variable is the body length. The independent would be the head.
Right. Because you're using the head length to
Okay.
predict the body length.
okay.
And for the margin of error,
You just plug that guy
Okay,
into
just a second. I'm almost done.
what?
not to mess somebody else.
Yeah, sorry, guys.
Okay. Okay, my margin of error. Hold on, what's the margin of error? Isn't the margin of error the midpoint between the confidence interval, or is it the difference between the midpoint and the confidence
It's
interval?
the difference between the midpoint. So
The
it's the
difference
upper.
between the midpoint?
So it's the upper minus the lower divided by 2.
Oh, right. Yeah.
So I get 0.442 for my margin of
got.
error.
Yeah, rounding, I get 0.443.
Did we double check the response variables on that, or the explanatory and the response? We put that in, right?
Well, I don't know if that would really.
Yeah, no, yeah, I just double checked it. It's good. So yeah, I think it would be the 0.443.
Oh, okay. What's your fourth decimal though? Because when I go to fourth decimal, I get 4424.
I'm gonna do it in Excel. I did it on my
Let me
iPhone.
round
So
it.
Okay.
Yeah,
This is a function. Oh, 442.
yeah, I have in Excel it's 0.4424. So
Right. So it'd be 2.442, not 3, right?
yeah.
Okay.
And then 7.218 for the lower bound.
As well, and then upper bound would be the 8.103.
Yep. Based on your lower bound and upper bound from the last two problems, what can you say about beta?
the first one. We're 95% confident.
Yeah, because you never use chance.
Right.
Okay, perfect. Well, do you want me to submit it?
Yeah,
Sure.
great.
I just hope it's 100 because I don't want to do more.
I know.
Yeah.
Okay. We have missed
Uh-oh.
one. Oh, that's weird. So, okay. Compute the residuals for the data using software. What statement best describes the residuals? I said the residuals form a linear pattern. This is question
What
6.
number is that?
Question 6. Thinking about it, I think it is actually the residuals are all negative.
Oh, that's true. They are all negative.
Well, I mean, I'm just thinking like if it's not that they form a linear pattern, I don't know why that wouldn't be it because they formed almost a perfect line. But I do believe that they're all negative.
No,
Let's plug it back in.
No, there's some
Negative.
positives.
Is there
Negative.
positives in there?
25. So I mean, if question 6 is wrong, the only other one it could be is residuals are between -40 and 25.
Yeah.
That's the range of them? Okay.
Yes,
Well,
that's the range.
okay. Well,
Is that the only one we missed?
yep, that is the only one we missed. So
Okay.
let me
I'll go ahead
exit
and
out of it
try
if you want to.
I'll go ahead and try it with the -40 and we'll see what that does.
Cool.
That is 100% with the
Change answer for
change
6.
it, change it from the residuals are between -40 and 25. And that will give you 100%.
Excellent. All right.
Skylar, do you need me to read off the answers to you or are you good?
Yes, please, if you could.
Absolutely.
Okay, so starting with 3.
3 is the third one down.
Okay.
Third one down for 4. Top for 5. Top for 6. Middle for 7. Top 3 for 8.
Okay.
12.695.
12.695.
Yes. And then 10 is 10.674.
Okay.
11 is 14.715.
Okay.
12 is the third. 13 is the last. 14 is the second. 15 is 0.442. 16 is 7.218.
Okay.
18 is 8.103. And then the top one for 18.
Okay, perfect. Okay, perfect. Thank you so much.
You're welcome.
Fantastic. All right.
I'll go
So
ahead and
Wednesday. Oh,
Yep. I'll submit and we'll see.